All right, I have this going through in chronological order and it's only on the second half of the year. Okay, so starting with unit 7, for a right triangle, A is 6 and C is 7, find B. It's Pythagorean theorem. So we're gonna do A squared, so 6 squared, plus B squared equals 9 squared. That will be 36 plus B squared equals 81. Subtract the 36. Let's see, what is that going to be? 45. Getting that in my head there. And then last up is square root. Now that one is going to split. How would you split up 45? 9 and 5, good. And so your final answer, 3 square root of 5. Cool. You're probably like, is that the only question from unit 7? No, there are other questions on unit 7. It's just they're on the calculator section because that was that whole law of sines, law of cosines. So that'll be at the end when we get to the calculator stuff. All right, unit 8. This was where I taught you the unit circles. So we learned about angles and rotation, and this is where that whole journey started. Finding negative coterminal angle for 4 pi over 3. You don't have to draw it, but I would. 4 pi over 3 is in the third quadrant. We've rotated this away. So negative coterminal angle is like, you go that way, I'll go this way, we'll meet on the other side. So the question is, how much backwards do you need to go to get to that exact same place? And it would be negative 2 pi over 3. All right, number 3, what quadrant is 2 pi over 3 in? Yep. Quadrant 2, that's it. What quadrant is it in? All right, in what quadrant is cosine positive and tangent negative? Cosine is the x value. So if your x value is positive, like you went to the right, so it has to either be 1 or 4. It has to be 4 because if something else is negative, it can't be quadrant 1 because everything is positive then. And then reference angles. They're either pi over 6, pi over 4, or pi over 3. Those are the only choices, and the denominator has to match. So this one would be pi over 6. That's like the easiest questions on there. The denominator just has to match. All right, and for this one, we're going to have to draw a triangle. It's going to be in the first quadrant because everything's positive. Cosine of theta is 4/5. Cosine is adjacent over hypotenuse. Now, I gave you this with the 4/3, but like, do you know this is going to be 3 anyway? Like, even if I hadn't said that, like 3, 4, 5. Remember your little locker combination ones? Okay. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so that's going to be hypotenuse over opposite, so 5/3. All right, I'm obviously going to tell you if you have all forgotten, but does anyone remember how to convert, what your conversion is, like what we're going to multiply this by? Oh, good. It's a pi over 180. So the degrees will cancel and the zeros will cancel, and you get 5 pi over 18. If that reduced, you would just have to reduce the fraction. It's multiple choice, so you'd have choices to look at. And then this one is the same thing except backwards. You're going to multiply by 180 over pi so that the pi's will cancel. If you don't get something to cancel, then you know you just did it the wrong way. So what I would do is the 180 divided by 9, that would be 20. 18 divided by 9 is 2. There's just a 0 attached, because then that's a whole lot easier. 10 times 20 be 200 degrees. And again, it's multiple choice, so you'll almost be able to like pick the answer if you just think about how far you rotated. Like, you'll be able to eliminate some choices is what I'm saying. All right, this is the bread and butter of pre-calculus. Like, if nothing else, this is the most important thing you've got to walk out of this room with, is being able to evaluate your unit circle. I'm going to go ahead and draw all the triangles and circles here. Obviously on the test, it's multiple choice and I'm not grading your work. So if you can do it without that, then that's cool too, right? So here's pi over 3. What goes across from that? Yeah. Square root of 3 over 2. Other side is a half. Tangent is y over x. So if you put this over this, the 2's are going to cancel and you just get square root of 3. All right, negative pi over 6. That means you've gone backwards pi over 6. That's going to put you in the fourth quadrant. Across from that would be negative a half And so the other side is square root of 3 over 2. So I kind of ran out of room there. All right, sine is which part of that? The y value, good, so negative a half. All right, 5 pi over 4 is in the third quadrant. What are both the sides going to be for that one? Good, and they are both going to be negative. Perfect. Cosine is the x value, so negative square root of 2 over 2. You almost can't mess that up there because it's the same thing. All right, where is 3 pi over 4? Which quadrant? Okay. Quadrant 2. And again, both the sides are square root of 2 over 2, but the x value one is negative. Cosecant means you're going to flip the y value. If you reciprocate this, you're just going to get square root of 2. You are welcome to flip it and then rationalize it if you want, but I think you're better off just knowing that one because it gets crazy with all the 2's in it. Then they end up canceling anyway. All right, negative 7 pi over 6 is going to put us in the second quadrant. We went backwards 7 pi over 6. Across from pi over 6 is a half. And then the other side, negative square root of 3 over 2. So cotangent is x over y. It's the reciprocal of tangent. So if you put this over this, again, the 2's are going to cancel and you will get negative square root of 3. All right, and then 5 pi over 3 is in the fourth quadrant. Across from pi over 3 will be negative square root of 3 over 2. Other side is a half. Secant means you're going to flip the x value. So what will that give us if we flip this? 2. Good. And then these last 3 are all like your compass points, like up, down, left, right. These are all going to be circles. Where is pi? Good. Left. Negative 1, 0. Tangent is y over x. So 0 over negative 1. I know this is like, I know it's either 0 or undefined. Which one is 0? If 0 is in the denominator, that's where you get undefined. All right, pi over 2 is at the top. Sine is the y value, so that's just 1. 3 pi over 2 is at the bottom. And secant means you want to flip the x value. So here's where we get an undefined, because you can't reciprocate 0. You can't divide by 0, so undefined. But I try to give you like one of each, like a sine, a cosine, a tangent, like it's one of each of them. Did they? Wait, here, let me, because this isn't going to make sense in the recording. Let me pause. All right, so unit 9 were all of these characteristics. There was one like this on the little breakout activity that we did. First thing I would recommend you do is rewrite the function. You're going to have to factor this. And also the 4, it tends to bother people when that's out front. So I'm going to put like the +4 at the end. It really doesn't matter, but it's just, I've found over the years that if you put it at the end, it doesn't bother everyone as much. So this will be -3 sine, and then we're going to have to factor out a 1/3. So dividing by a third is the same thing as multiplying by 3. So you want to really think of it like you're distributing a 3 through there. So it's going to be x minus 3 pi. If you're like, I struggle with that, the only thing it's going to mess up is the phase shift. That's the only thing you need to factor for. You'll still be able to answer everything else. That's the only question that you need though. All right, so range. This would be centered at 4 because it moved up 4 units. That's like where our center is, and it's going to be a wave. How far are we going from the center? Yeah, 3 units in each direction. So what's our low point going to be? It'll be 1, and then the high point 7. Okay, so your range would be from 1 to 7. You don't have to draw a picture. Obviously, again, I'm not checking any of your work. It's multiple choice, but the picture helps me, so draw that. All right, again, you guys did this like 2 classes ago on that breakout thing. How do you find the period? Yeah, 2 pi over, and then whatever's in front of the x, which in this case is a third. So that will give you 6 pi. Phase shift, you have to look at the factored version. We went right 3 pi, or you could just say 3 pi, like positive 3 pi. What is our amplitude? Good. I was gonna say a little tricky, but it's not negative because it's a distance from the center. So you just like absolute value that. And then vertical translation is 4. Those aren't too bad. You just have to factor the problem. All right, unit 10 was our inverse trig. So these are the ones that are really picky about the quadrants. Let me just really quick recap it. The odd ones are in quadrants 1 or 4. The even ones are in 1 and 2. So odd is 1 or 4, even is 1 and 2. And the only even ones are cosine and secant. So when you look at 23, we're going to do this inside part first. That's positive, so it's going to be in the first quadrant, which is nice. Cosine is adjacent over hypotenuse. And so what's the other side? Good. And then you're going to do tangent of that. So tangent is opposite over adjacent. So that would be 4 over 3. All right, cosine, and it's negative. So that's going to be in the second quadrant. It's either 1 or 2. Oh, whoops, or 1 or 1. Huh. 1 or 2, and since it's even and it's negative, it's in the second quadrant. So the negative 1/2 goes here. That means the other side is square root of 3 over 2. And so what does that make your angle? Pi over 3, but your final answer is how far you rotated to get there, which would be what? 2 pi over 3, good. All right, this one is odd and it's negative. So that's the fourth quadrant. Now this is kind of tricky. When it's tangent or cotangent, if it comes out to 1 or -1, what does that mean the sides are? Yeah, it has to be the same. That's the only way that you can end up with 1. So the angle's pi over 4, but your answer is not pi over 4 because you rotated backwards to get there. So it is negative pi over 4. This one's positive, so first quadrant, sine is the y value. And across from that, you get pi over 3, and that would just be your answer because you're in the first quadrant. That's one you almost kind of don't need a picture for. You can kind of just think through that one. And then if you get a secant or a cosecant, I would flip it. The reciprocal for cosecant is sine. And so it'll be sine inverse of 1/2. Just flip it over. So it's positive. We're in the first quadrant. And so what is our angle for that one? Pi over 6. All right, unit 11 was all of those identities. I made them all ones that you can just answer. There's not going to be steps. Do you remember those ones we had steps to it? Like you had to replace and then cancel. These are all just like, do you remember the flashcards we did? It's all just those. Okay, so just you can answer them. So what is cosine over sine? It's cotangent. Oops, I almost put theta. I put x on these, whatever. So if that's the one I put on here, which one do you think I put on your exam? Reciprocal for secant. Cosine. Tangent is odd. The odd ones go negative. So this will be negative tangent. The even ones stay positive. So like secant and cosine would stay positive. This is probably the hardest one on there. Cotangent squared plus 1, it's one of those Pythagorean ones. It's cosecant squared. It, like, to be really honest, if you want to let that go, like, give that one a guess. You know what I'm saying? All right, and then whenever it's the 90 minus x, that's the co-function. You just add or remove a co. So since this is cosecant, if you take away the co, it would just be secant. So yeah, I made them all ones you can just answer. There's no like work to them. All right, this is one of my favorite topics that we do is solving the equations. I think solving an equation is something that's like familiar to us. What would you do to both sides for this, just to start solving it. Add 1, perfect. Now these do have steps to them, because you have to actually like solve them. All right, divide by square root of 2. And then if you rationalize that, it will be square root of 2 over 2. So then you decide what quadrants you're in. Cosine is the x value, and this is positive. So that would be in quadrants 1 and 4, looks kind of like a kite, sort of. And what is the angle for the square root of 2 over 2 triangle? Pi over 4. And you get 2 answers. The first one's pi over 4, because that's just in the first quadrant. But how far did you rotate to get down to the 4th quadrant? We go forwards for these. 7 pi over 4, there we go. I did not give you any of the ones, you know, where you rotate like a couple of times around? I didn't put any like that on, just once around. Right here, you would add the 1/3 and then square root. Now, when you put a square root, that means you have to put plus or minus. And then when you square root a fraction, I know fractions scare everybody. Just do the numerator, then do the denominator. Square root of 1 is just 1. Square root of 3 is just square root of 3. If you don't have a calculator, it's just square root of 3. Now, this is the tough part. You have to like go backwards a step. It would be 1/2 over square root of 3 over 2. But if you get stuck, it is either 1/2 over square root of 3 over 2 or square root of 3 over 2 over 1/2. Do you know what I'm saying? Like it is one or the other. So you got a 50-50 shot. Now, because it's plus minus, what quadrants are we in? All of them. It looks like a bow tie, which is cool, so you don't have to worry about it. Cotangent is x over y. So the 1/2 is the x, square root of 3 over 2 is the y. And that means your angle is pi over 3. And we're going to get 4 answers for each of the triangles. So it'll be pi over 3. What else? 2 pi over 3. This is like keep calm and know the unit circle. 4 pi over 3. 5 pi over 3. Lovely. Now, when it says all solutions, that's where you add the thing with the n. Remember, plus 2 pi n plus pi n. So that's what that means. So for this one, you would add 1. Let me move this up. Divide by 2. And then decide what quadrants you're in. So it's sine and it's positive. So what quadrants is sine positive in? Yep, 1 and 2. Looks like little kitty cat ears. And your angle is pi over 6. So for this first one, it would be pi over 6, and you have to go the whole way around to land there again. So you would add what to go the whole way around? Yep, 2 pi n. And then we're going to do this one. You have to do them separately because they're not evenly spaced from each other. So what's this one? 5 pi over 6 plus 2 pi n. And then lastly, unit 12, this is our polar stuff. Convert this to rectangular form. That's going to land on the axis. So if you just draw it, you'll be able to answer it. If you rotate to pi, that's going to be over here. And 5 units away from the center, that's your point. So what would that be in rectangular? Yeah, -5, 0. Like that's a no work one. And then this, we're going to have to actually work it out. X equals r cosine theta and y equals r sine theta. And again, you're either going to memorize that or you're not, and going to give it a guess. It's like one question. So cosine of pi over 3, if you think about your pi over 3 triangle, the x value would be 1/2. So this is square root of 5 times 1/2. And then sine of pi over 3 is your square root of 3 over 2. And then you just have to write the answer as an ordered pair, x comma y. So nothing really cancels out here. It'll just be square root of 5 over 2. And then, oh, these we can multiply together though. That'll be square root of 15 over 2. If it looks like a mess, you probably did it right. And then with these two, we're going to go back the other way. So to get r, it's x squared plus y squared equals r squared. Just your Pythagorean theorem. And so what will that give you? 2. 1 plus 1 is 2. When you square a negative, it's positive. And so r is square root of 2. So you know it's gonna, like, your theta has to be something with a fourth in it. Do you get what I'm saying? Like if it's that square root, it's gonna have to be a fourth. If you just think about where this point is, what quadrant is the point 1, negative 1 in? Yeah, it's in the 4th quadrant. So like how far did you rotate to get there? And it has to be fourths. Yeah, 7 pi over 4. Or you, because remember how there's an infinite number of answers, what else could you say? Negative pi over 4. Although you can't though, because on the exam it's multiple choice, but you'll be able to see it, like, and pick the right answer. All right, and then this one's going to be on the axis. So if you just kind of draw it and look at it, or just visualize it in your mind, if we want to put that in r comma theta, r would be 4, you're 4 units away from the center, and how far did you rotate to get pi over 2? So I'm going to tell you if it's a right triangle or not a right triangle, which is called oblique. Those are the ones that you need law of sines, law of cosines. So 40, for a right triangle, so go ahead and draw a right triangle. And A and B can be wherever you want, but C has to be the right angle. So it says A is 32 degrees, little c is 11, find little b. And remember, little a goes across from big A, little b goes across from little b, and so on and so forth. So it's going to be SOHCAHTOA. It's going to be sine, cosine, or tangent. Here's your point of view, because this is the one we have labeled. B is adjacent, and then 11 is the hypotenuse. So if we have adjacent and hypotenuse, which trig function is good? Cosine of 32 degrees equals b over 11. You have to multiply the 11 over. So what you're going to type is 11 cosine 32. We're going to start with the calculators cleared just for fairness reasons for the exam. So I have cleared the memories on all those calculators. What that means is you need to put it in degree mode. So go to mode and change it to degree. You will catch it if it's in radian mode, because when you type it in, your answer won't be there. So like you will catch it. And I'm going to remind you to change it on the day. Change it to degrees, and we're going to type 11 cosine 32. So 9.328. So that's just SOHCAHTOA. Sine, cosine, or tangent, type it in your calculator. And actually, you know what? Let me save these for last. Let's skip down and do 44 and 45, because those are going to be really similar. They're just word problems. These are going to be right triangles. You are standing 200 meters away from a building. So this is the building, the vertical part, and you are standing here. Where does the 200 go? Yeah, horizontal, it's along the bottom. You're 200 meters away. The building is 135 meters tall. What is your angle of elevation? All right, so do we want sine, cosine, or tangent? Tangent. Tangent of x equals 135 over 200. Now, how would you type that, since it's the angle that you want? Yeah, inverse tangent, perfect. So it is second tangent, and then 135 over 200. And then this one is ladder leaning against the side of a building. So it's going to be a right triangle. The ladder is 18 feet long. So where does the 18 go if that's the ladder? That's the hypotenuse. Perfect. It touches 13 feet up the side of the building. So that's going to be the vertical part. And again, we want the angle of elevation. So is that one sine, cosine, or tangent? Sine. Good. We have opposite and hypotenuse. So sine of x equals 13 over 18. And again, you want inverse. So you're going to hit second sine 13 over 18. All right, and then these last three, this is your law of sines, law of cosines. And again, we did some of these on that breakout activity, so hopefully it won't be like too rusty. So an oblique triangle, that just means it's not a right triangle. So I don't care what it looks like. I just draw something with three sides. It's not to scale, right? B is 42 degrees, and you want to start with the bottom left and then go to the bottom right. So B is 42 degrees. I'm going to call this angle A. Side A goes across from that. That's 13. And then side C is 16. We don't have little b. You do need to know the pattern because that tells you whether you want law of sines or law of cosines. So this pattern is what? Yeah, side angle side means law of cosines. Okay. And again, you're either going to memorize it or give it a guess. All right, there's only 3 questions on this on there. Okay, so for law of cosines, it will be b squared equals, if I get you started, could you maybe finish it? Like what comes next? We did b squared equals, good, 13 squared plus 16 squared. Good, 2, and then you repeat those, 13 times 16, cosine of the angle. Now it's b squared equals, but it says find b, so we're going to type in our calculator what? Good, square root of all of that, and that will give you your answer. And you know how I had told you to store that and then you had to reuse it to find other stuff? It's not like that on the exam. All I asked you to do was find B, you found it, you're done. Yay. Did you guys get 10.76 stuff? Okay. So 42, just draw something with 3 sides, doesn't need to be to scale. A is 72, C is 20 degrees, and little b is 8. So what is this pattern? Angle side angle, that means law of sines. So you need a side across from an angle, which we actually don't have. This is the only side we have. So I need the angle across from that to set up the ratio. It's easy to get though. How do you get the angle that you're missing? Yeah, subtract the other ones from 180. So we're gonna do 180 minus 72 minus 20. This would be 80, oh, it's 8, and then across from that is 88. Oh, well, that's what it came out to. So when you set it up, it's gonna be 8 over sine of 88. Sorry about that, that's a little crazy with the 8s. Equals, now which one am I asking you to find? C, so it'll be C over sine of 20. And you're going to cross multiply and divide. So you will type 8 sine of 20 divided by sine of 88. And it kind of makes sense that that is a really small side because it's across from a really small angle. It's only 20 degrees. And this side was only 8. So like it makes sense that that's smaller. All right, last one. Draw yourself a triangle. I realize this is an obtuse angle. I guess you could draw it as obtuse if you want, but again, like it just doesn't matter. It's not ever going to be perfect anyway, so I usually just don't worry about it. Little b is 2, and then little c is 7. So what is this pattern? Side-side angle. Now, when it's the naughty word spelled backwards, that's the one where you have to like go through the flow chart and figure out like what it is you need to do. So do you remember how it starts? If not, I'm obviously going to tell you, but. Good. All right, so theta is obtuse. And then you compare the opposite and the adjacent. So the opposite, which is 2, opposite that angle, is what compared to the adjacent? Smaller. What does that mean? If it's not big enough, no solution.